Alright, I just watched the last one and I just want to apologize for seeming like I am not focused. Um, and for using some crass language, as in, yeah, I didn't swear, but I said inappropriate words for school. Alright, let's fill in some blanks here. The uncertainty principle, when applied to the electron, states that it is inherently impossible for us to know simultaneously both the exact location of the electron and its exact momentum or velocity, if we wanted to write it that way, in space. Okay? So if you watch that video, that says we can't know both. So instead of now, just kind of follow me here, instead of now having this positive center with these negatively charged electrons going around in these defined orbits like Bohr said they were, we can't put them on an orbit because now we could say, the electron's right there, idiot. I can see it. We do not know anymore where it is. So Bohr's model goes right out the window. All right. It doesn't work anymore. So now this principle, and it was in the little video that we showed, we say here's the nucleus, and the electron resides in certain areas of probability, areas where I will most likely find the electron. Now this is going to look pretty familiar. Alright, I have a circle, but this time the circle isn't somewhere where it resides, it's something where it probably is inside of. Alright, so for instance, if I asked, alright, let me start over. If your parents wanted to find you on a Thursday at 10, pretend you're in my class right now and it's 10 o'clock, so third hour you win the prize. Alright, so it's 10 o'clock and your parents want to find you. They do not know exactly where you are. They don't. But they know that you are in the school somewhere. You are most likely to be found in the school. There are times when you are not at the school at 10 o'clock on a Thursday, but the most likely place you are is in the school. And even a higher probability, if you're in my third hour, that you are in the classroom. All right, they don't know exactly, and sometimes you're there, sometimes you're not. But in general, you are in my classroom at 10 o'clock in the morning on a weekday if you're in my third hour. All right, that's what we mean by a probability. It's not always going to be true, but it is more than likely the case. All right, so now this one, first one is a circle, and this will get way more complicated. The second one is actually a circle also, even though that looks like an egg or a really ugly potato. Pretend it's a circle. But after we get the second level, like they used to be rings, the first two are circular places where we'll most likely find the electron. Then we start throwing in some really strange shapes. That was pretty good. Alright, this would be what the third one looks like. It's called the 2P. You have to imagine another one going in and out of this board. Alright, this shape's going to get very complicated pretty fast. Alright, let's fill in some blanks in the next 40 seconds. Erwin Schrödinger in 1926 proposed an equation that incorporates both the, I don't know what order they go in, but don't care, the particle and wave-like behavior of the electron. This is known as the wave function. The wave function is the mathematical equation that defines these voluminous areas of probability where you should most likely find the electron.